Okay, we're going to talk about H11N.2. We're going to be doing Euler's method, and we're not going to be using the fancy calculator steps yet. We're just going to be doing it the old-fashioned way with just doing simple arithmetic with the calculator. So, this first part, you should have copied these notes from Miss Castro. You should have gotten something like this. And then for the other part, you should have gotten something like this. And now we're going to do an example following her advice. Okay, so the thing we're trying to do is we're trying to figure out a coordinate. So we want to find the value of y when x equals 0.5. This is what we're trying to find, because no videos say, why are we doing Euler's formula? We're just like, oh, this is how you do it. But they don't say why. We're trying to find the y coordinate when x equals 0.5. Okay, so we've got our slope formula here, and we've got an initial x value and initial y value. So my initial x value is 0, my initial y value is 1. Okay, and the first question, we're going to have a step value of 0.25. So if we start at 0, the next x value is going to be 0.25. Okay, so now, given my initial step of 0, my initial x value of 0, my initial y value of 1, I'm going to try to figure out the slope. So, and I'm going to use this formula, e to the 0 plus 1. And that's going to give me, well, anything to the 0 is 1, so I have 1 plus 1, and that's going to give me 2. Okay? So my derivative is 2. So my new x value, so if my step is 0.25, that means I'm going to add 0.25 to 0, and I'm going to put it right there. So my new x value is going to be 0.25, and the new y value is you take the old y value of 1, right? The old y value is 1, plus the step size, which is 0.25, times our slope, our derivative formula, which is 2. Okay. Now, if you don't understand what I'm doing and why I just did this, watch Miss Castro's video, because she explained why we're doing what we're doing. Okay, so I simplify this with my calculator, and I get 1.5. That should make sense, because a quarter of 2 gives me 0.5, plus 1 gives me 1.5. Okay. Anyways, the calculator steps, I'm just going to assume you know how to do a calculator, and I'm going to just talk it through. Okay, so my new y value is 1.5. So I'm going to transfer that and put that right here. So my next point was 0.25, 1.5. Okay, so now I'm going to use these values to find my next new slope. So the next new slope is e to the power of 0.25 plus 1. Okay, e to the power of 0.25 plus 1 is approximately 2.284. I'm going to assume that you know how to use your calculator to calculate this. And then the next x value is going to increase by 0.25 and 0.5. Okay, and then the new y value takes the old y value. The old y value is 1.5 plus the step size. The step size is 0.25. And then the new slope we just found out was 2.284. And so I'm going to have 1.5 plus 0.25 times 2.284, and then I put that into my calculator, and then I get 2.071. So therefore, when my h is 0.25, my step, this is my step. I'm keep going up in 0.25 steps. so I only need to go up 2 steps to get the value. The y value is going to be 2.071. Okay, so so this is my slope, this is my derivative, right? My step is 0.25. 0.25. I'm going to try to use these colors throughout the assignment. Okay, so I'm going to be using the derivative or the slope with orange. My step, I'm going to try to use blue. And my initial step is 0 and 1. So 0 and 1, those are my initial steps. Okay, so my final coordinate is 0.5, comma 2.071. Okay. Okay, so I'm going to go through the calculator steps later in a different video. This entire video is about doing this by hand. Okay, so let's, same question, and now we're doing part II. We're going to have a step size of 0.1. Okay, so once again, we start off with when x is 0, y is 1. When x is 0, y is 1. Okay, and now I'm going to figure out my derivative. Once again, I'm going to use this formula to find my derivative. And so, just like before, I have e to the 0, because x is 0, right, plus 1, and that's going to give me, anything to the 0 is 1, and 1 plus 1 is that's going to give me a value of 2. Now, if my step is 0.1, then we're going to keep adding 0.1. So this new step is going to be 0.1. Okay. 1, 2, 3, 4, 5. Okay. These are steps. Okay. The new y value is the old y value, which is 1, plus the step size. My step size is 0.1 times my new slope, which is 2. Okay, now 2 times 0.1 is 0.2, and 1 plus 0.2 gives me 1.2. Okay, now this is my new value. I'm going to put it right there. This is my new y value. The new x value is 0.1. Well, the x values keep increasing by the step. If it's the next one after that, it's going to be 0.2. The next one's going to be 0.3. The next one's going to be 0.4. Right? This next one's going to be 0.2, 0.3, 0.4, 0.5. We're going to stop because we want to find the y value. We want to find the y value when x equals 0.5. That's the whole reason we're doing this. Okay, so these are the only columns, the x ones. These are the only ones that we can just fill in like this. Okay, everything else, the y, the next y has to be affected by the slope and the old y, or the new y. Anyways, let's go through this process again. So these are the only columns that I can fill in advance. Okay, so once again, my slope formula is e to the x. X here is 0.1 plus 1. So if I do e to the 0.1 plus 1, on my calculator I'm going to get 2.105. Okay. And then, so now I'm going to take my previous y value, the old y1, which is 1.2, plus the step size. The step size is 0.1. And my slope, we just calculated the new slope, which is 2.105. Okay. And so I calculate that. And once I put it into my calculator, I get 1.41. Okay, next. Now that becomes my the next y, 1.41. Hope you start seeing the process here. So now I have e to the power of x. Power of x is 0.2, and then plus 1. And this is going to give me the new slope at this point, at 0.2, comma 1.41. The new slope at that point is 2.22. And now the new y value is going to be the old y value of 1.41 plus the step size, which is 0.1, times my new slope, which is 2.22, and that's going to give me a value of 1.63. Okay, now I write that new value here, 1.63. I hope you guys are seeing the process. Okay, this goes here, 1.63 plus 0.1 times this new slope, 2.3498, and then I get 1.868. Okay, 1.868, my new slope. And then I'm going to take that old y value of 1.868 plus the step size, and my new slope, 2.492, and then I get 2.117. Okay. So this is the y value when x is 0.5. Okay. So okay. So therefore, when I have a step h of 0.1, my y value is going to be 2.117. Okay. And question B says, find the exact value when I use the fundamental theorem of calculus. So we're going to do like what we did in an earlier section, where I have dy dx equals e to the x plus 1. So using differential equations, I can multiply both sides by dx, and I get dy equals e to the x plus 1 times dx, right? We multiply the dx on both sides, and now I'm going to take the antiderivative of both sides. Okay, and then the antiderivative of dy is simply y. The antiderivative of e to the x is e to the x, and the antiderivative of 1 is x, and then we have to have plus c. And now we need to solve for c. And when we solve for c, we have x equals 0 and y equals 1. Right? That's from these initial values right here, when x is 0, y is 1. Okay? Okay? So, and that's going to help us figure out C, the particular solution. Okay, remember, this is the general solution. Okay, and now we're going to find the particular solution for C with those points. So if y is 1, I have e to the 0 plus 0 plus c. I just replaced y with 1. I replaced x with 0. And then I have 1 equals, and anything to the 0 is 1. Okay, 1 equals 1 plus c. So that means c has to equal 0. Therefore, c equals 0. The 3 dots means therefore. Okay, so now this equation becomes, so our equation is simply e to the x plus x. This is our particular solution. Okay, and now we are going to find the value of y when x is 0.5. Okay, we know using Euler formula with a step of 0.1, we know the answer is this. Now let's find the exact solution using calculus. So if I plug in 0.5, we have y equals e to the 0.5 plus 0.5, right? I plugged in x, put 0.5 in for x, and then I get y equals 2.148. And this is the exact value of y when x is 0.5 using calculus differential equations. Okay. Now let's make a comparison when so when I had a step of 0.1, we got this answer. When we did it exactly, we got this. It's kind of close. And on part I, our answer was 2.071. That's kind of close, but if we look at the answer, because here we had a step of 0.25, here we had a step of 0.1, and notice this when the step got smaller, we got an answer that was much closer to the exact answer. So it's better to have smaller steps to get closer to the real answer. Okay. This is one with the calculator steps. I'm not going to go over that. I'm only going over the ones where we are doing it by hand right now. Okay. Let's see, we're at 18 minutes. I'm just going to walk you through one more, and then I'm going to show you the answers to the question 2. I'll just show you the work done. Okay, so let's walk through this one here, starting with our initial step of 0 and 3. Okay, so 0 and 3. That's our initial point. Our steps go 1, 2, 3, 4, 5, right? And our step size is 0.1. So I can fill that in right now. 0.1 will be the next one, 0.2, 0.3, 0.4. So if I added a step, I would have 0 0.1, 0 0.2, 0 0.3, 0 0.4, 0 0.5. Because we're trying to figure out, well, it doesn't say how far to go, but they want you to do 5 steps. Okay. So, oh, I guess they want you to go up to 0.5. Okay. So, so now we got our derivative here. Okay. So we're going to use this definition. And remember, like we said before, this is going to be the old y, so the old y plus the step size times the derivative, dy dx, or the slope. So my step size is the h value 0.1. Okay. So let's plug this in. So, all right, x value is 0. The y value is 3, and then minus 1. Okay, 0 times 3 is 0, and then minus 1, that gets me negative 1. Okay. So the old y value is 3, plus my step size is 0.1, and the derivative here is negative 1. Okay, and that simplifies to 2.9. Hit pause if you ever need to just take a break. What the heck just happened? Da, 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 da. Okay, this new 2.9, that's my new y value. Like I said, hit pause, take a break, drink some coffee, have some tea. Tea. Okay, so now I'm going to use these 2 points to find my new slope. The x value is 0.1. The y value is 2.9. Then minus 1, and that's going to get me my new slope of negative 0.71. Okay, so that is my new slope. Okay, now the old y, which is now 2.9, plus my step size 0.1. The step size, you may have noticed at this point, the step size just stays the same. The blue value just stays the same. If we look at the earlier example, the blue value stayed the same. The step size doesn't change. It's the slope, the derivative, that changes as we move along. Okay, so negative 0.71. And so this plus this times this is going to give me 2.829. Okay, I'll do one more, and then I'm just going to show you the answers. Okay, so I'm going to move that 2.829, and then I'm going to use these values to figure out my derivative. The derivative is x times y, so 0.2 times 2.829, and then minus 1, right? And then that's going to give me an answer of negative 0.434. Okay, so now let's take the old y value of 2.829 plus 0.1 times this new slope, which is negative 0.434. And we use my calculator, and we get this new value is 2.7856. Okay. And it goes on, and you get a final value. You might want to hit pause, but you get a final value of this. Okay. I could go into the plot, but I'm not going to right now because that would take too much time. And so the next one here, I'm just going to show you the steps because I did this already. So same process. Okay, the step size was 0.25. Okay, the old y value, we started off with 0 and 2. Okay, the colors that I'm using specifically, I'm going to use those same colors when I start doing the calculator steps on my next video. Okay, now on part II, we're going to have 5 steps with step size of 0.1. So here, my step size of 0.1, and you're going to see the x value increases by 0.1 each time. And then, just like in the previous one, my initial point, we started off with 0 and 2. Okay. The derivatives changed, as you see here. And I took the new y plus the h value, the step value, times the new derivative or the slope, and that gets me the new y. That goes here, times the step value, times my new slope to get the new y, and so on. Plus the step value times the new slope to get the new y. Okay. So, and then part B, once again, said to use the fundamental theorem of calculus. Let's just kind of step through this. And then, so I multiply dx on both sides. Then I took the integral of both sides, and then I get y equals 3/2 e to the 2x minus x plus c. We're going to calculate c. So we're going to make x equals 0 and y equals 2. Those are the values, our initial values that we started with to calculate c. And then I end up with plugging 0 in for x and 2 in for y. So now I have, from this equation, I have 2 equals 3/2 x to the 0 plus c. So e to the 0, that's just 1, right? So 2 equals 3/2 plus c, so c is going to be 0.5. So here is my particular solution. Particular equation. Not solution, it's an equation, isn't it? Particular equation. And then, so now I'm going to calculate the value at 0.5 because that's what we're trying to figure out. Why are we bothering to do all of this in the first place? We're trying to find the y value. They should just write this in bold. Find y when x equals 0.5. It's like, hello, what are we doing? We're trying to find the y value when x is at 0.5. And so with the step of this had a step of 0.25, this had a step of 0.1, and then using calculus we got this. So you can see the step of 0.1 is kind of close. The step of 0.25 is in the ballpark, but not as close. Okay, and that is it for this video. On my next video, I'm going to show you how to do it with the calculator.